Hey everybody, welcome back to episode 2 of Every Last Byte. So today we're going to talk a little bit more about the chip that's actually running our programs when we write something up in Arduino. So the Arduino Uno board itself, you could think of it as a development board or an artist tool, but it's a board that has a chip on it, and that chip is the Atmega 328P. So in this case, that chip is what's reading the instructions and actually executing, turning pins on and off and blinking your LEDs. That's the thing that's sending the signals. And so we're going to kind of crack this thing open and take a look at what's going on inside. So if we were to really crack this thing open, probably just get a bunch of crap, like some silicon, I don't really know. But we're going to crack open, crack it open symbolically, I guess. And so, if we were to crack it open, I guess symbolically, you'd see something like this. Which, so as a side note, I just ripped this out of the data sheet. It's like page 4 or something. It's really early, and it should be. It's kind of like a roadmap as to what's going on inside the chip. And luckily, it's a bunch of boxes, so it's pretty simple. But it is complicated at the surface level. Even there's a bunch of arrows going everywhere. But we can kind of pull some interesting things out of this diagram. So first, you can see the CPU. That's kind of like the processor that's eating the instructions and doing some basic math and writing things to memory, reading things from memory. Here's our memory, and here's another chunk of memory. That's SRAM, a different type. And then there's a bunch of other boxes. So more or less, these are kind of the guts of how everything else is kind of made possible when it comes to interacting with the physical world. So I want to turn on an LED. The processor itself can't actually do something like that. Or if I want to write some data over serial, the processor can't do that either. In one sense, you can write it so it does do that, but it's not worth your time. So long story short, the processor is the thing that reads your program and executes it. But what it's actually doing is it's actually telling a lot of other things to execute your program, especially if they're if they're a lot more complicated than something the processor wants to deal with. So a good example is, let's say I want to blink something. I just want to turn a pin on and off. And so what the processor is going to do, it's not actually physically connected to a pin, but there are other things that are physically connected to pins. So if we look down over here, there's something that says port C, B, D. These are what we can call kind of block diagrams that represent ways of interacting with the pins on the Arduino or on the Atmega chip. So the agreement is I can send information and put it into port C, and then port C will look at that and actually turn on and off pins depending on what's going on inside of port C. You can almost think of the processor as turning on and off a bunch of switches on a bunch of features. And so overall, kind of the way to look at this diagram is to think of it as, think of this microcontroller overall as like a processor with features. And each one of these features makes very high level tasks a lot easier than just having the processor do those all at once. So I want to turn some pins on and off. You've got these ports over here. I want to communicate with some device digitally over SPI. I've got this SPI block diagram over here that knows how to speak SPI. If I want to do serial communication, I've got this creature over here that knows how to speak serial. If I just give it the data to send, it will send it the correct way. So yeah, overall this block diagram, it's a processor with features. The processor eats your instructions and tells other things to do very high-level things. The processor can also do some pretty basic stuff, pretty simple math, can write variable values back to memory, it can read stuff from memory. It eats your instructions one at a time, but the complicated stuff is handled by a lot of these other boxes over here, these features. And these features are called peripherals. I probably won't refer to them as peripherals, but I'll just call them features for now, and probably later on too. But that's kind of like the overall guts of what's actually happening inside of the Atmega chip overall. So yeah,